Linear probabilistic modeling, a not-so-linear relationship. Linear regression is used to predict the linear relationship between x and y. The linear probabilistic model is a special case of linear regression that assumes the expected value of y is a linear function of x, but varies from the regression line at random amounts. To account for random variation, we use the probabilistic function y equals beta naught plus beta 1 times x plus epsilon, where y is dependent, x is independent, beta naught is the y-intercept, beta 1 is the slope, and epsilon is the random deviation. In this model, y is represented by 1 or 0 for the success or failure to reach the goal. The random deviation factor epsilon represents all of the random factors that contribute to y's random variation from the regression line. The expected value of epsilon is 0, and the variance of epsilon is the squared distance from the regression line. The regression line can be found using the least squares method. First, find x squared and x times y for each observation. Then the sum of x, the sum of y, the sum of x squared, and the sum of x times y. Then calculate the slope, beta 1, and the y-intercept, beta naught, where n is the number of observations. Finally, compile your equation of the regression line. Relationships can be a roller coaster sometimes. Here, we have an example of a roller coaster running a course with different weights added on each time. As you add weight to a roller coaster, the more momentum it has, causing it to complete the course faster as you add people to each row. Here you see the times vary from the line due to factors such as wind and temperature. These are what constitute for the random factors that epsilon is representing. The trends shown can be used to predict how fast a roller coaster might run the course with different weights every day. The probabilistic model is used to find the general tendency of a nonlinear relationship to make predictions for the future, making it a great tool for engineering.